Alright, so quick demonstration of this new triple module down here. It's a pulse stretcher, clock divider, and quantizer. I have the trigger output of this sequencer going into the pulse in. Pulse out is going to both the filtered EG and the VCA EG, so it's split with this cable. So when the trigger output is coming out of this sequencer into the pulse stretcher, I can modify the pulse length and make the notes staccato or legato, like this. So you see this light is on steady, and if I decrease the pulse width, the notes become more separated until the gate time becomes really short. And that is just a 555 timer set up with variable pulse width triggered from here. So you can make the notes connect completely if you want. And it's a little bit more fun saying when the clock rate is turned up. It makes more difference. Connect the notes completely, or completely disconnect them for a very percussive effect. Okay, next part is the clock divider, and we move this down here. And now the trigger output is going into the clock input of here. So now every time this triggers, it will be divided by whatever number here on this dial and sent to the envelope generators. There's 2 divided in half, 3, 4, 5, and so on, all the way up to 10. There's divide by 10. 1 doesn't work in this mode. It just goes blank because the trigger signal is upside down. So 2 works there. Now one thing that works very well is to combine these 2 units, take the trigger output and put it into the, leave clock in, and then we connect this to pulse out, and connect one to the other. So now it's going into the clock and then out to the pulse stretcher, and you get the best of both worlds. It divides, but you have the variable pulse width. And if you turn up the release on the envelope generators, then you can hear the clock divider better. All the way out to 10. And in this mode, step 1 works to divide by 1, which is nothing. Just leave it on. And then you go to 2, turn down the release, and so on. Okay, now the other part of this module is a voltage quantizer, which, quite frankly, I'm pretty proud of. We take the control voltage from here, from the sequencer, and instead of going directly into the oscillator, we patch it through to the input of the quantizer, and then the output of the quantizer goes to the input of the oscillator. So now, instead of being kind of random bleeps and bloops, we have a quantized output, which is a musical scale. And in order to demonstrate what the quantizer is doing, got a lot of cables in the way here, I will take the output of this oscillator and patch it around the filter like that, and then we'll move this here. Oops. And now we're on this stage. If I move this, the voltage will be quantized into 25 discrete steps. So now, instead of, if I want to program in a musical scale, all I do, because the lights of the quantizer are arranged in the manner of a keyboard, C, C sharp, D, D sharp, E, F, F sharp, G, and so on, you can program visually. So if I want to program in a major scale, I can simply do it C, D, E, F, and so on like that. So and so on like that. And what a light show. Now, one thing that's really fun to do, I'll patch this back, route that through the filter, is to take the step out, the divided clock output of the clock divider, and make it trigger another sequencer. So we can do that with another patch cable. And what we do is we take the clock out, pulse out, and connect it to the DC trigger in of this one, and now we can take the control voltage from the second sequencer and route it into the second oscillator. And then when we hit run, we have this divided by the ratio of the clock divider, but this on the original ratio going to two different with all sorts of musical mayhem, because of course this is not quantized. This is going straight in, and I don't know how I have this tuned. This is going through the quantizer, so it's in something of a musical scale. But there's all sorts of fun that can be had, especially in divide by 2. So, there you have it, a demonstration of this triple module.